So this is the recording or the video for vectors 4, which is where we're going to be talking about position vectors. And this is a kind of new way of us thinking about vectors, or a new way of using them. What we're going to say is that position vectors are a vector that's used to define a point in space relative to a fixed origin. Okay, so what we've done is we've looked at vectors previously and we've said that they're not kind of specific to an area of space. They're not like a coordinate is. But this time we're now going to fix one end of that vector at the origin, some point that we define. And that means that the other end of the vector can kind of help us kind of identify a point in space. Okay? So I can do that without the use of a coordinate grid, which is useful. It allows me kind of more freedom, really. And I can say, for example, that I can let a point A has a position vector relative to the origin of -2, -4. And I can say, well, here's my origin. Okay? And that means my point A must be here because this vector defines it, where this is 2 steps across to the left and 4 steps down. Okay, so -2i minus 4j, or -2, -4 is a column vector. And just so, and obviously this then is the vector OA, okay? And any vector which comes in that form, OA, OB, OC, all the way to kind of OZ, is usually a position vector, okay? Where O is our origin. So that's usually a position vector. If you see this, then we're talking usually about a position vector. And these can be really useful for us. So I can kind of use it to define specific coordinates. Now this is something we won't do loads of, but it is something you need to be aware of. We need to be happy to go, okay, so here's a point 2, 5, so that's therefore going to have the position vector 2, 5 or 2i plus 5j. Okay. Now just to check that we're comfortable with that, I'm going to put another 3 questions on the screen. If you could pause the video and have a go, and then check back for the answers once you're finished. And those are our vectors. Obviously the only one that's a little bit more tricky is when we've got a 0 involved here. There's no x component in the coordinate, so there's no x coordinate in the vector, and there's no I coefficient in the ij vector. We can also use position vectors to solve problems, and we will be required to do this. And this is a key skill for as we develop into mechanics. One of the ways we really use vectors in mechanics is to define positions and displacements. So let's have a look at this question. I've got a position vector of A, where OA is 5i minus 9j, and a position vector of B, where OB is 7i plus 2j, and I want to calculate the vector AB. Now, this is a simple question, and some of you might be immediately tempted just to have a go or to kind of work some stuff out, but I'm going to say it is a simple question if you draw a diagram. Okay, if you don't draw a diagram, this is going to get very, very difficult. Now, this diagram is going to be a sketch, and this is the skill. The hardest thing here is drawing the right sketch, or getting a sketch that's usable and workable for you. So my first step is I'm going to define some origin. Okay, I'm going to define some origin. I'm going to work with my first vector, O to A. Now, I'm going along 5, so 5i, I'm going along 5, and then I'm going down 9. So my kind of second point A should be over here somewhere. Okay, so I'm going to draw it here. Now that means I've then got my vector O to A, which is 5i minus 9j. I now want to think about where to point my point B. Okay, and I'm trying to be in general vaguely accurate. I'm trying to get the right sector, right? So this is my origin, 7 across, 2 up. Okay, it's going to go slightly further than the point A, and it's going to go 2 up, so around about here, and there. Here we go. I've drawn it my point B. And as I said, this isn't exactly accurate, right? This is not to scale, but it in general does work. Okay, and then I've got this vector OB. Now at this point, I've been asked to find A to B, so I'm going to draw on here the result of that vector I'm trying to find, which is A to B. And at this point, it's easier now for me to work out what my pathway is. So I want to find the vector A to B, which is going to be A to O plus O to B. So that's negative O to A. Okay, and this is O to A. And then I can just substitute my values in. I'm going to work with column vectors because we know it's easier, but it's negative 5, negative 9, plus, sorry, negative lots, minus 1 lots of 5, negative 9, and 7 over 2, or 7, 2. That gives me 2, 11, and then I'm going to, as always, put that back into I and J form by convention. We want to give my answer in the form in which I was given vectors in the original question. So 2i plus 11j. Okay. So drawing this diagram helps me to be able to answer this question and pick the pathway appropriately. The key thing is we're not always clear on which way these arrows are going. We can be tempted when we get a question like this just to add these together, okay? But that's not what we're doing here. We're actually subtracting one from the other, okay? Because we're going backwards down one of these. Let's look at a slightly different example, but again, it indicates the need for this sketch. We're going to say let the position vector of C, OC, with the vector OC equal negative 3i minus 9j, and the vector DC equal negative 2i minus 10j. And I want to calculate the position vector of the point D. So the difference here is I've been given a different vector, and I want to find a position vector. But my process is the same. Draw the diagram. Start with defining my origin. It can be useful to give you space all the way around, so you can put the points wherever you need to. Now, negative 3, negative 9, I'm going to go across 3, I'm going to go down 9, so that my point should be around here. There's my point C, and I've got this vector OC. That's my position vector of C. I then have got a point DC, where this vector, okay, is going to be from D to C is negative 2, negative 10. Okay? So if my point D needs to be somewhere, so negative 2, negative 10. Now, this point is harder to place, and it doesn't really matter where you put it. You'll get the right answer as long as you've done the maths right, okay? It can be useful to try and think of where it'll be, so you've got a bit of a sense check, but don't worry too much, okay? And that gives me this vector, D to C. Now, the vector I'm trying to find is the position vector of D, which is then this vector here, from O to D, okay? Now, it's important I get the direction right here, otherwise I'll be in trouble. But now I can start thinking about what pathway I can use to find this vector O to D. Okay? So I know O to D is going to be O to C, subtract DC, or C to D, so subtract this vector DC. And then I can substitute my values in. Negative 3, negative 9, take away negative 2, negative 10. This negative will make these positive, and I'll get my answer negative 1, 1. And then I can convert that back into I and J notation. I get I, negative I plus J. That's my final answer.